Hello students, welcome back. In this video, we're going to add our core gameplay mechanic to Broshi. That's going to come in the form of falling colored blocks. So this is going to be the heart of our puzzle. Our falling blocks will fall in one of our 6 columns and they'll move down one row at a time until they hit the bottom of that row and they'll stop. Those blocks will stack up on top of each other, and if that stack gets too large, the game will end. The way we reduce that stack is by matching colored blocks. So if a colored block lands on top of a block of the same color, those blocks will get removed from that column. So let's head over to our computer screen and we'll dive right into our lesson. So I have lesson 3's starter file open here in vscode.dev. I'm going to minimize my browser here and go to my Broshi folder and open up lesson 3 directly. So let's see what we got to work with. So here's our start overlay and no falling blocks. We could wait here for a very long time. I don't think any falling blocks are going to show up because that system is completely broken. So let's come back here and let's begin working on lesson number 3. Mission 1 says we got to create a new block with our correct data. All right, so I'm going to hit Control F here to open up my search bar, and let's go see where Mission 1 is. And it finds us in a function called Generate Block Data. So we're diving right in here. Oftentimes, before we dive right in, we should get an overview of what we have to work with in this new system, because we are implementing a brand new system, a falling blocks system. So let's click in our search bar over here to go back to our mission checklist, and let's go to our student edit zone. Let's see what values and variables we are working with. So if it looks like we've got 3 new things here. We've got block wait frames, 36, block fall frames, 12, and blocks per spawn, 1. So these are going to be variables that are going to control how long we wait before a block begins falling, how many frames we wait before a block will move, and then how many blocks we're going to spawn at a time. So this is just going to be a debug. So we're going to start with just 1 block, but if I wanted to spawn like 3 blocks at once, I could change it. So our wait frames, the blocks are going to appear up here and they're going to wait 36 frames before they begin moving. So we're going to see where they are. That'll give us time to react. Then they'll begin falling. So they'll fall, bloop, and they'll fall 1 row every 12 frames. And so that's going to be that system right there. All right, and so now if we look, what's in our color palette? Oh, we've got some colors for some of our new blocks. So we're going to have a red block, a yellow block, a blue block, and a purple block. And all of those colors are defined there. And it looks like we're storing all of those colors in an array inside of a container. So I can reach into this container and grab the red block color or the yellow block color or the blue block color or the purple block color, of course. And let's look at what gameplay variables we have. All right, it looks like we've got 2 new gameplay variables. Both of these are arrays or containers that are going to hold multiple things. So I have an array called columns with a comment here that says these are for finished blocks. These are going to be static. And then I have an array called active blocks, and with a comment that says, hey, these are for moving blocks. They are going to be dynamic. I think it might be helpful to draw a picture of what this is going to look like, what our game is going to look like with these 2 arrays in mind. So let's head over here and let's open up a whiteboard, and I'm going to draw a diagram here. So I'll draw my game world and I'll put some columns. So here's my game world. Zoop. All right. And I've got 6 columns, right? So there's 1, 2, oh, hit the erase button. All right. And then 4, 5, and 6. And then I'll just throw some rows in here. All right, arbitrary rows, doop, 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 perfect. And so these are our column numbers, 0, 1, 2, 3, 4, and 5. And so I have an array called columns. That array is going to hold each of these individual columns. And each of those individual columns are going to be arrays because they will hold individual blocks. So for example, maybe I've got some purple blocks. I've got a purple block here, a purple block here, and a purple block here. And maybe I've got a blue block. So I got a blue block here and a blue block here. And then I'll do, I don't know, some red blocks. So I'll put a red block, and a red block. So imagine that is what we have. So those are static. These are all static. They have landed. They're not moving anymore. So we would put them inside of the columns array. So our columns array is going to be this big wide container that is going to hold other small containers. We're going to have a container for our first column. Boop. So there it is. And it has 2 blocks. So it would have a purple block and a blue block. And then we'll hold the container for our next column. Well, it's empty, so I'll just make it an empty column. And then we have a container for our next block. Okay, our next column has a purple block. And then our next column, so I'll make a container. It's got a purple block and a red block. And then our next column, which is empty. And then our next column, which has a blue block and a red block. So that is all of our static, non-moving blocks. But then we're also going to have some blocks that are falling. So let's pretend let's spawn 3 blocks at once. So maybe I spawn 3 blocks. So I put a red block here that's going to be moving down, and I'm going to put a yellow block. Did we have yellow as one of our colors? I think we did. A yellow block and then a purple block. So those are the spots that I chose to spawn. So now active blocks is another array, and that is going to just hold the blocks that are currently moving. So it would hold a red block, a yellow block, and a purple block. And so we're going to leverage those 2 variables, those 2 containers, to help keep track of the current state of our game board. And we're going to say here that these blocks right here, these active blocks, are going to have 2 sort of properties or states to them. They could be waiting. So they could have appeared on the screen and we're going to have some time to react, right? They show up and we're waiting. They're not yet moving. We're going to see where they are so we as Broshi can react to begin swapping columns, or they could be in the falling state. And that's where they would then begin moving down and down and down. All right, so with that sort of overview there of what we're working with, that defines those variables for us, hopefully quite nicely. Let's take all of this and let's now go to mission number 1. Mission number 1 finds us in a function called generate block data. All right, so we are introducing a brand new object into this world. We're introducing a block object. And anytime I bring in something to a game, like a brand new system or something that I'm going to physically, visibly place in the game, I like to use 3 functions. I have a generate block data, I have a spawn blocks, and then I have an update blocks. So we got to generate data for the object that we're going to put into our world. And then we want to spawn that object into the world, and then I want to update that object. So that is going to be a repeated structure that I use over and over and over again. Like let's say I want to have a power-up. I'll generate the power-up data, I'll spawn the power-up, and I'll update the power-ups. Maybe I want to have enemies. I'll generate the enemy data, I'll spawn my enemies, and I'll update my enemies. Now, in generate block data, it looks like we're taking in a column. We're going to take in some information. What column do I want to generate my block data for? So I'm going to know what column I want to be in. And all this function is doing is returning an object. So there's curly brackets. That object represents a single block, a single falling block. And if you look, it has lots of properties. It has a type property, a column, a row, a color, a mode, a wait timer, and a fall timer. Now, we have to set some of these values because they are not right. The block type, right now, we are only dealing with colored blocks. They're red, they're yellow, they're blue, they're purple. Those are all color blocks, but we're going to see some other types of blocks later on in the game. Right now, the column is set to be column 0. It is hard-coded, meaning our blocks are always going to get created in column 0 right here. That would make for a very bad game. We don't want that to happen. We are going to set the column to be whatever the column was that we passed into this function. So let's set the column property to col, the value that we got passed in. Our row is going to be set to row count, which is currently 13. Well, let's see. Do we want to spawn in row 13? Well, this is row 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 would be the bottom. Ooh, that would be bad. It would be like down here. It means like we're done. We have 13 rows. This is like way down here. We don't want that. We want to spawn at the top. So we're going to spawn at row 0. We've got 13 rows, 0 through 12. So row count being 13. We don't want that. Let's spawn at the top. We're going to spawn at row 0. And then our color is currently set to null. That means no data. We don't want our color to be no data. We want to set the color of our block. If you remember, we had a list or an array called block colors where we stored red, yellow, green, or what was it? Red, yellow. Let me go check. Red, yellow, blue, and purple, all here in this list. I'm going to randomly select from that list. So we're going to get a random color for our block. The way we do that is we call the random function random, and then we pass in the array that we randomly want to choose from. So we'll randomly select block colors. Hey, I think our block data structure is complete. This represents a single block. The mode when we create it is going to be set to waiting, and our wait timer, which is currently set to 36 frames, will decrease that, and when the 36 gets to 0, the wait timer is up, we'll change the mode to falling. And then our fall timer will kick in, and we'll wait 12 seconds, and we'll fall 1 row. Wait 12 seconds, and fall 1 row. We'll keep that going, on and on. So right now, our data structure is complete. If we refresh our game, do we have any falling blocks? Oh, bummer. No falling blocks. Well, that just means we got to go to mission 2 because all we did in mission 1 was generate data for the blocks. But mission 2 tells us it's time to spawn the blocks. So let's look here. We have a function called spawn blocks. The first thing that we do is we look and see, hey, if our current active blocks array, our container that's currently holding all of our active blocks, if that's greater than 0, it means there's already blocks in the screen that are falling. We don't have to generate any more. If the length is greater than 0, just get out of this function. We don't want to spawn new blocks. But if it's not greater than 0, if it's equal to 0 right now, then there are no active blocks in the game. We got to make some. So we create a new array called shuffled columns, shuffled cols, because essentially what we're going to do is we are going to randomly shuffle the order of our columns because I want to randomly place my active blocks in a column. I don't want them all to go like 0, 1, 2. I want them to be randomized. And then we push into this new array, and push is how you add something to an array. So we push into this brand new array our columns, all right, our column numbers, and then we shuffle those columns. So instead of being column number, 0, 1, 2, 3, 4, 5, I could have columns 2, 5, 0, 1, 4, 3, which is going to help us when we go to spawn our blocks. But the first thing we got to do is we got to figure out how many blocks we want to spawn. So we're going to spawn the minimum value of our blocks per spawn debug, or the length of shuffled columns. So right now we're only trying to spawn 1 block. So we're always going to pick, 1. But let's say if we accidentally change blocks per spawn to say like 7, well, we don't have 7 columns. The length is only going to be 6. So we're going to pick the smaller of the 2, and so we'll pick 6. All right, and then the magic happens because we use something called a for loop. So we are going to use a for loop to loop and create the correct number of blocks. We let a variable I equals 0, so I starts at 0, and I will continue to go until it is less than our spawn count variable. In this case, it's just going to be 1, and then we increment I by 1 each time. So the for loop will run, and our code inside of here is going to get executed, and then we would increase I again, execute our code, increase I again, execute our code. And this will happen until that variable I is no longer less than our spawn count. So if we look, we pick a column out of our shuffled columns list. So we start with the first column, then the second column, then the third column. We just go down the row of the shuffled columns. And now we want to spawn a block. The way we spawn a block, how do we get a block? Well, we call the generate block data function. Okay, tab for autocomplete, set of parentheses to call it, semicolon for good JavaScript. When we call this function, we are returned or given back to us this object. So this object gets back to us, it's returned back to us and is now right here. But we need to do something with that. We need to put it in an array. We have two arrays to hold blocks. We have columns and we have active blocks. These are currently active blocks. So we're going to call that array active blocks. And we're going to say dot push. And we're going to push into that array whatever is given to us from the generate block data function. So now let's see what happens if I refresh my page. Nothing yet. So we're pushing that data, but what do we now have to do? So let's go look at mission number 3. Mission number 3 says we got to update our blocks. Okay, so mission number 3, we're going to update our blocks. So what's happening? Well, in update blocks, we call spawn block. We just looked at that. And then we're looping through our array. Oh my gosh, students, I got ahead of myself. We need to stop. We have to go back to mission 2. We made a critical mistake. I made a critical mistake. If we look here, we are calling in mission 2, in order to spawn our block, we're taking our array, active blocks, and we're pushing into it whatever is given back from the generate block data function. If I go and look at that generate block data function, we explicitly said here, we're going to give it a column. We have to tell it what column we want to generate our block in. And right here, when I'm calling that function, I am not giving it that information. I am not telling it what column I want to spawn our block in. The column that I want to spawn our block in is right here. It's selected from our shuffled columns list. So I need to plug in or send in that column. And now that I do that, let's refresh our game. There is my block. Look at that. So if I restart my game, I should get a different block. I do, and it's in a new position. If I restart, ooh, there's a red one. Restart, there's a purple one. Restart, purple, restart, yellow. And so my blocks are showing up. Now, right now, we are only generating one block. So if I want more blocks, I just go up to my student edit zone, and I can change the blocks per spawn debug. Let's set it to 3, and let's see what happens. There's 3. All right, we'll restart. And so we're getting perfect different colored blocks in different positions. This is working perfectly. And now it gives us the motivation for our next mission, because if you look, those poor blocks, they are completely stationary. They are in waiting mode. If you remember, when we updated when we created our blocks, right here in generate block data, the mode was waiting. They are going to wait until wait time frames, that timer gets to 0. So I'd like them to change. I'd like them to begin to move. So now let's officially head to mission number 3. Mission number 3 finds us in update blocks. So when we update our blocks, we spawn blocks, and then we loop through all of our active blocks. Now, if you notice here, we're looping through our active blocks at length -1. And then instead of adding to I, we're subtracting I. And so this is a nice little lesson here. So let's say active blocks has block 1, block 2, and block 3 in it. We have 3 blocks, as you see right here, 1, 2, and 3. Those are going to be my active blocks. We're looping through this backwards. Remember, every array has a length, and the length right now of this array, length, is going to equal 3. So I'm looping through, letting I be the length, 3 minus 1. Well, 3 minus 1 is equal to 2. And so what does that 2 correspond to? Every element in an array has a position. It starts at 0. And it goes by 1. So our last element is always 1 less than the length. So we're starting at the end of our array, and we're going to decrease I by 1. So we're going to start at position 2, then position 1, and then position 0. Right here, by typing the name of our array, square brackets, and then putting in a number there, allows us to reach in and grab the block at that specific position. So when I is 2, we grab the block at position 2. When I is 1, we go in and we grab the block at position 1. And when I is 0, we go in and grab the block at position 0. You typically loop through an array like this, starting at the end and going to the beginning, looping backwards, anytime you want to remove something from an array. So why would we want to remove a block from the active blocks array? Well, eventually it's going to land and it will no longer be active, which is why we're looping backwards through it. So I grab for all of those blocks in the array, I grab the current block and I check to see if its mode is waiting. If its mode is waiting, I decrease its wait timer property by 1. Remember, we set that, I think, to like 36 frames, so I subtract it by 1. And then we hit mission number 3, wait to fall. It says update the block mode, switch from waiting to falling. So it says if we ask another question, that block mode's wait timer is less than or equal to 0. That means it is now time to transition our mode from waiting to falling. We do not want to set our block mode to waiting. Let's set it to falling. And then we continue. What continue does is it skips the rest of the code for this particular block and it goes to the next one. So let's see. Let's update this now. So now we should switch to falling mode. Okay, let me try that again. We should switch to falling mode. I don't think one more time is not going to do it for me. We should switch to falling mode. Nope, nothing. Because while we have switched, this block is now in falling mode. This block should be in falling mode. And this block is in falling mode. They clearly do not yet know what to do given they are in falling mode. So let's go to mission number 4. Mission number 4, I'm not even going to search for it. It's still going to put me in update blocks. If I scroll down a little bit, we have mission 4 right here. It says move the blocks down 1 row. Update its position over time. So this finds us in a big if statement where we ask the question, if our block is in falling mode, what do? Well, we take our fall timer and we subtract 1 from it. And if that fall timer is greater than 0, meaning we still have time left on the timer, we just continue. We skip over the rest of the code for this block and we go to the next one. But if the fall timer is not greater than 0, if it's at 0, then it is time to move. So we reset the fall timer and then we begin moving our block. So to move our block, what I need to do, it says here in mission 4, we got to update its row. So our block has a row. Our block has a row property, and we want to add 1 to it because when we started, our block was in row 0. We want to move it to row 1, then row 2, then row 3. So let's just add 1 to it. So we'll do plus equals 1. And then we continue. We just say, hey, we moved the block. Now don't bother checking the rest of this code. Go to the next block. Let's see if our blocks now move. Hey, look at that. Our blocks are falling. And they're still falling. What? What just happened? They like went through the game board. This is not. So they're falling and then they just keep going. We don't want that. Eventually we need the blocks to stop. So we got to make sure we know when the block stops. And I think that's going to put us here in mission 5. See, we're asking a question. And so our question is always true. And so that means this block of code right here is always going to run. We're always going to move our blocks down 1 row. We don't want that. So we got to ask a question. When do we want our blocks to move? Well, we want them to move if the row that they're in is, this is row 0, row 1, row 2, row 3, row 4, row 5, 6, 7, 8, 9, 10, 11, 12, right? So if their row number is less than the row that they're going to land in, then we move them down. So how do we get the row that they're going to land in? Well, if we look up here, we've got a couple of variables that will help us here. So I have const blocks in column, and it looks like we go into our columns array, and we grab our current block, its column property, and we get the length of that column. And then I have a landing row variable, which is row count minus blocks in col minus 1. So these variables are a little bit challenging to understand on their own. So I'm going to draw a picture here in the whiteboard to help us out. So that picture was great for us, but now we're going to draw a brand new picture. And I'm going to assume, just for simplicity, let's make our game board only have 2 columns. So I'm going to draw 2 columns, a 2-column game board. All right, so there is my game board. Here are my 2 columns, and I'll make 6 rows. So And those rows are numbered 0, 1, 2, 3, 4, and 5. All right, and these columns are numbered column 0 and column 1. So our columns array, that array is made up of 2 other arrays. And let's assume that, let's assume that this column 1 has nothing in it and column 2 has some blocks in it. So column 2 has a red block, right here, and it has a purple block, just like that, okay? And so if I were to write out my columns array, I would say, all right, my first column has, it has a purple block and a red block. All right, so we'll say a red block and a purple block. And then my next array, my next column has nothing in it. And so we are going to just focus on this first element right here. We're going to focus on this row, or this column right here. So let's put a block in here that's going to fall. Let's give a yellow block. So our yellow block is going to start falling. It wants to move down. So our row count, let's figure out what is row count. Well, row count is the number of rows that we have. So if you look here, our block is in row 0. So our block is in row 0, and we're going to get the blocks in that column. So our column is column 0. So we're going to go to our columns array, and we're going to grab that 0 element. So we're going to go grab what is at index 0. So remember, in an array, these exist in positions 0 and 1. We're going to grab that, and we're getting its length. So its length is 2. So I know now that we'll start with block in column is equal to 2. All right, our row count is, we got 0, 1, 2, 3, 4, 5. That's going to be 6 rows. And so now we're going to figure out our landing row. Our landing row is going to be right here. It's in row 3. So how do we get that? Well, we're going to take our row count and we're going to subtract our blocks in column, and then we're also going to subtract 1 from it, because let's see the math working out. So 6 is our row count minus our blocks in column. 6 minus 2 is 4, but remember, we start counting at 0, so we subtract 1 more. 6 minus 2 minus 1 gives me a landing row of 3, which is exactly where we want to be. So we're going to check to see if our block's current row, so right now in this state, our block's current row, block.row, is equal to 0. And when it moves down here, it's going to be equal to 1, and then it'll be equal to 2. And as long as it is less than 3, which is how we got our landing row right here, we're going to keep moving it down. So that is the math that explains how we're going to check that it's time to land a block. So we're only going to move the block down a row if the block's current row, block.row, is less than the landing row variable. And that landing row variable was derived right here. We defined it right here, and that is what our math explained. So now let's check it. Let's run this and see if our blocks stop moving. Please stop moving once you hit the ground. Hey, yes, that worked awesome. Let's just see it again, because I was so excited about that. Perfect. So that is excellent. That means we can now move on to our next mission. We can move to mission number 6. Mission number 6 is, it says, stack insertion. Add blocks to the column. Store it as a finished block. All right, so this finds us in a function called resolve block landing, and it looks like this function is taking in a block. So where are we calling resolve block landing? Okay, so in update blocks, which is the function we were working in, right? We have our blocks fall, we check our landing. Once that's all done, if we're not moving a block anymore, remember, if we move a block, we say continue, which means skip over the rest of this code for a given block. But if we don't move a block anymore, we call resolve block landing, and we pass in the block that we have. So in here, it looks like we get the column of our block, and we get the number of blocks in that column. All right, and if the number of the blocks in that column is greater than 0, it says, let's figure out what that top block is. Okay, so now I know what the top block is, and it says, All right, mission 8, we're going to check colors. We'll come back to mission 8. But now mission 6 says, okay, a block has landed. Add the block to the column. Store it as a finished block. Hey, I know how to add a block to a column. So we have an array called columns, remember? And it was going to be for our static blocks. So if I come back up here to my gameplay variables, remember we defined columns for our finished blocks that are static, active blocks for our moving blocks, they're dynamic. Well, right here, the block has landed. So we're going to move it out of active blocks and into our static blocks. But I have to make sure that I put it in the right column. So in here, we're going to say columns. We're going to reach into that array and we're going to grab whatever the column number is of the block that we're working with. Perfect. So now I know, okay, this block is going in like column 0, column 1, column 2, column 3. And to put it there, we use push. We're going to push something into this array. But I don't want to push all of the information about our block, right? You can stay here. I'll jump back up to where we defined our block data. We got the type, the color, the row, the color, the type, the column, the row, the color, the mode, the wait timer, the fall timer. The only thing that I really need to keep track of now, because the block is now static, it's not moving, its column's not going to change, its row's not going to change, its mode is not going to change, the timers are not going to change. I just want its type and its color. And it's those things that I'm going to check when we collide with other blocks. So I'm only going to store as an object the type, and the property will be type, and we'll get its value from our block's type property. And I'm going to store the color. So we'll have a color property, and we'll get its value from the block's color property. Awesome. So now when our blocks fall, all right, they're currently active blocks, and now we have just pushed the, what is this? What weird behavior is this? I don't understand. Our blocks are falling, they're active blocks, we add them to columns, so they're static blocks, and then they just go crazy, they go haywire. Well, it's because we're adding them to our static columns array, marking them as static blocks, but we're never removing them as active blocks. So we now have to take care of that step. See, we need to transition them from active blocks to static blocks. We made them static, but now we have to remove them from being active. And so mission 7 finds us back in update blocks. We resolve our block landing for the given block, which means it is no longer active, it is now static. We have to remove it from our active blocks array. The way you remove something from an array is by typing the array's name, active blocks, a tab for autocomplete. And then we are going to use the splice method, so .splice. Here, you have to specify the position in the array that you want to remove from. Thankfully, we are going to remove from position I. Remember, we reached into our array and we were working with a block at position I, whether it was position 3, 2, 1, 0, anything like that, working backwards. So we are going to remove from position I. And then you have to specify how many blocks you want to remove starting at that position. I only want to remove 1. All right, so now when we add the block to our static column array, we then remove it from our active blocks array. Let's check it out. So now, hopefully, we do not get that weird stacking behavior. Oh, perfect. And then more blocks spawn. Look at that. That's working awesome. They just keep growing and growing and growing. All right, but what I would really like is, I got purple on purple, yellow on yellow. They should disappear, right? Those blocks should cancel each other out. And so the last thing that we're going to do here is we're going to go to mission number 8, and that puts us back in resolving our block landing because we need to clear on a match. So it says, check if colors match. Remove matching blocks from the column. If you remember, we said in resolve block landing, we get our current column, we get the number of blocks in our column, and then we find the top block in that column. So right now, that top block is purple. We can check purple and blue. Top block is purple, purple and purple. That should be a match. So we need to ask a question. Right now the question says false. Well, false is always going to be no, so this code is never going to run. But if it does run, we take the column that we're in, the column that the current block is in, and we pop from it, which means we remove this last element that's inside of it. So the last element here would have been removed, and then we call return, which means get out of this function. Don't do anything else. Don't do anything else like add that current block to our static columns array. So we would remove this block and never add this block. And that block, if you remember, is getting removed from our active blocks array. So both of those blocks will disappear. We just got to ask the right question. Well, we want that to happen when their colors match. So we're going to look at our top block. So top block is right here. We grabbed that. And we're going to check its color property, top block.color. And we're going to check to see if it is equal to 3 equal signs for a check for equality, our current block's color. If that is the case, we're going to pop the top block and never add our current block. And with that, our falling block system should be set. Let's take a look. Let's see if we can watch this. Ooh, 3 purples all at once. Let's see if we get any colors that are going to match up here and we can see them get removed. Hopefully we don't have to wait too long. Okay, yellow right here. We should see yellows match up. And right there, they were disappeared. Here, red should match up. Perfect. This is working out nice. Yellow should get disappeared. Perfect. All right, purple should disappear. Very good. All right, so this is working really nicely. Now, what I would really love to be able to do is swap some of these. Like right there, if I could swap those columns, those purples would have canceled, and we would have reduced some of our column stack here. But right now, we do not yet have that functionality. And I think that functionality is a great thing that we're going to try to add in our next video. So I'll see you then.